Hey class, so my name is Miss Stone. I'm your teacher for this semester. I guess I'm going to be teaching you online for the first chunk, and then we'll see if we end up going back. But anyways, today's our first lesson. It's called Number Systems and Rational Numbers. So I uploaded a blank version of this. So this is the note. You guys are going to copy this down, and I will talk you through it. And then at the end of this, I have a picture of what your homework is, but I also will upload it separately so that you can print it off and do it from there. Okay? So remember, because this is a recording, you can pause me at any time and rewatch the video as many times as you need in order to make sense of anything. Okay, so we're talking about the number system. This is a little bit of a review from last year, and just to help get us into the math groove. Okay, so we have natural numbers as our first one. It's represented by a capital N, and it is all counting numbers. So 1, 2, 3, 4, 5, 6, 100, 200, 3 million, 4 million. Okay, and it just keeps going on. Then we have whole numbers, and it's represented by a capital W. And it is the same, only it actually includes 0. So you'll notice here it goes 0 and then continues on. Then we have integers. It's represented by a capital I, and it's positive and negative numbers and also includes 0. Okay, so dot, dot, dot just means it continues lower, and dot, dot, dot continues past 3. Okay, then we have rational numbers, which is represented by a capital Q. And they are all numbers that can be written as fractions. Okay, so a half, a third, a quarter, 5/8. Okay, but it does not include 0. And then we have irrational numbers. So it looks the same. It has the Q, only it has the little line up above. And it's all numbers with non-terminating and non-repeating decimals. Okay, so not like a repeating decimal would be like a 0.33333333. Okay, and then we have real numbers that are represented by, it looks like an R, which has an extra stick, and it's all the numbers. Okay, so all real numbers. And then we have imaginary numbers, which is represented by an I. And so, for example, you can't take the square root of a -1, okay? You can't take the square root of a negative number. So, in this case, if you had -16 square rooted, we know that the square root of 16 is 4, but because it has a negative under the square root sign, we put an I with it, okay? So that's how you can represent the imaginary numbers. And down here, it says rational numbers are really fractions. Okay, so next slide. Types of fractions. So there's the mixed fraction. It has a whole portion and a fraction portion. So for example, this example right here is 3 1/4. So the 3 is the whole portion and the 1/4 is the fraction portion. Then we have improper fraction. It's a fraction where the numerator, which is the fancy word for top, is larger than the denominator, which is the fancy word for bottom. Okay, so improper fraction here would be 16/3. The numerator is 16, the denominator is 3. So if you were to switch that over to a mixed fraction, okay, 3 goes into 16 5 times, right? Because 3 times 5 is 15. And then to go from 15 to 16 means that we just have to add 1. And our denominator stays the same, 3. Okay, so 16/3 is the same thing as 5 1/3. Then we have equivalent fraction, a fraction that represents the same ratio. So for example, a half is the same thing as 2/4, 3/6, 100/200, okay? 50/100, okay? It just keeps going on. A little note here, multiply or divide the top and bottom by the same number. So for here, to go from like say 1/2 to 100/200, if we multiply both by 100, okay? So 1 times 100 gives us 100, 2 times 100 gives us 200. Okay, so we just multiplied both numbers by the same number on the top and on the bottom. Okay, next slide. Remember, pause and rewind as many times as you need. We're talking about converting fractions now. So mixed fractions to an improper fraction. So we have 2 1/6. Okay, so what you do is to change it to an improper fraction, you take the denominator 6 and multiply it by 2, which gives us, so 2 times 6 gives us 12. And then we have to add the numerator, which is the plus 1. So 12 plus 1 gives us 13. So that's why we have a 13 on top. And then our denominator was 6, so it stays 6. Okay, improper fraction to a mixed fraction. So just reverse. So right now we're going to start with 26 over 4. Okay. And so over here it says how many times does 4 go into 26? So actually, yeah, no, it's all good. So 6 times 4 is 24, and we have up to 26. So we have 6 can go in there for sure. And then we have 2 left over, right? Because 6 times 4 was 24. So we had 26 to choose from. So 26 minus 24 leaves us with 2. And our denominator is 4, so it stays 4. But then notice that this is 2 over 4. We can actually reduce that into simplest terms. And 2 over 4 is the same thing as 1/2. So we can rewrite that as 6 1/2. Okay. And then last one, reducing fraction to the lowest term. So if we had an example like 30 over 40, well, look over here. Divide the top and bottom number by the same number, okay? So here we have 30 and 40. Well, if we divide them both by 10, we can get it smaller. So 30 divided by 10 gives us 3. 40 divided by 10 gives us 4, okay? Another example here. 3/9, so 3 over 9. If we divide the top number by 3, 3 divided by 3 is 1, and then 9 divided by 3 is 3. So 3 over 9, its lowest term would be 1/3. Okay? And down at the bottom it says, don't forget, mixed fractions need to be changed to improper fractions before doing any calculations. Okay? So mixed fractions have to be changed to improper fractions before doing any calculations. In order to add or subtract fractions, we need to have the same denominator or a common denominator. And if there's no denominator, we use a 1. So for example, if you just had the number 9 and there was nothing underneath it, it's assumed that there's a 1. Okay? If we had a 12, there's no number underneath it, we assume that there's a 1. Okay, so we use a 1 underneath because 12 divided by 1 would give us 12, which is the same. 9 divided by 1 gives us 9, which is the same. Okay, so let's go to the next slide. Adding and subtracting fractions. So the first thing you want to do is change mixed fractions to improper fractions. Then you are going to find a common denominator, that's your bottom number, and write each fraction using the new denominator. Then you're going to add or subtract the numerators once the denominator is the same. And then you're going to reduce to lowest terms. So if we look at this first example, 2/3 and 1/5, you want to find a common denominator. Can 3 go into 5? Nope, not easily. So we want to just take both denominators, 3 and 5, you multiply them together, and our common denominator can be 15. Okay? Next example, 1/6 and 11/12. So we have a denominator 6 and a denominator 12. Okay? So what you can do is you can do the same thing that we did up above, 3 times 5. So here, 12 times 6 gives us 72. So that can be a denominator, our common denominator. But we always have to go to lowest terms. So if you also notice that 6 times 2 gives us 12, then we can just skip right down and use 12 as the denominator. And then we don't have to reduce at the end. Okay? So next slide. So just a couple examples. We have 3 over 7 plus 2 over 7. So if you notice already, the denominators are both 7. So we can rewrite it like this. Put the 7 on the bottom, and then on the top we just have the 3 plus 2. Okay, 3 plus 2. And then 3 plus 2 we know is 5. So our new fraction is 5 over 7. Next example, we have 4/9, so 4 over 9, subtract 1/9. Okay, so they already have the same common denominator, so we can keep the 9 on the bottom, and then we can just rewrite the top to 4 minus 1, and that's why we have here 4 minus 1. So when you simplify 4 minus 1, it gives you 3. So it ends up with 3/9, and then we can reduce that. 3 divided by 3 gives us 1. 9 divided by 3 gives us 3, and we're left with 1/3. Next one, C. We have 3/5 plus 7/10. So if we look here, we know that 5 times 2 can give us 10, so we can have our denominator, or our common denominator, is 10, and we just have to multiply both the numerator and denominator by 2. So 3 times 2 gives us 6, 5 times 2 gives us the 10. Plus 7/10 stays the same, okay? And then because we have our denominators both 10, we can rewrite this, okay? So 10 stays on the bottom. And then on the top is just 6 plus 7, which is 6 plus 7. Okay? When you add those up, you end up with 13 over 10. And then we know that is a improper fraction. So we can change it to a mixed fraction. So 10 goes into 13 once, so we have 1. And then we are left with 3/10 left over, and you can't reduce that anymore. Okay? So D, we have 2/3 minus 1/4. Okay, so we don't have a common denominator. We have a 3 and a 4. But if we multiply those both together, we can get 12 as our denominator. So we'll multiply this whole fraction first by 4. So 2 times 4 is 8. 3 times 4 is 12. And then we have our subtraction. Okay? And then the second one, we're going to have to multiply both the numerator and the denominator by 3. So 1 times 3 is 3. 4 times 3 is 12. So now we have the same denominator, 12. And then we're just going to simplify the top. So 8 minus 3. And then when you simplify 8 minus 3, it gives us 5 over 12. Okay. E. So if we look here, this one's a little bit different. It already gave us a mixed number, so we need to turn it into an improper fraction. So 6 times 1 is 6. 6 plus 1 is 7. So that's where we came up with our 7/6. Then subtract 2/3. So subtract 2/3. Now we need to have a common denominator. So this one is a 6. This one is a 3. So if we were to multiply this fraction by 2, it'll give us the common denominator of 6. So 2 times 2 is 4. And 3 times 2 is 6. So now we have our common denominator as 6. And we can simplify the top. 7 take away 4. 7 take away 4 gives us 3. So we're left with 3/6. And then we can reduce that even more to 1/2. Okay, F. Now we have two mixed numbers. So the first one, 4 times 1 is 4. And 4 plus 3 is 7. So that's why we have 7 over 4. And then our plus stays the same. And this next one, 6 times 2 is 12. 12 plus 5 gives us 17 over 6. Okay? So now we have a denominator of 4 and a denominator of 6. So in order to find a common denominator, we can multiply these two together. 4 times 6 could give us 24. Or if you noticed that both of these numbers go into 12, okay, that works too. So 4 times 3 gives us 12. 7 times 3 gives us 21. So we have 21 over 12. And then we're adding them, so the adding stays the same. And then we have 6 times 2 gives us 12. And 17 times 2 gives us